Director and all the faculty members are arrived.
The theme of the community presently but this is the thing that nuclear energy and giving support to the related frontier areas of science, DAE also has been the cradle for the space.
Absolutely.
So from here we start the space research part. So
long association.
Yeah, long association towards Albert. Just after the launch of the Sputnik, thought that space program should start in India. And right in the beginning, we have letters in the archives from 1959 when he is asking Menon to come for a meeting, where he is calling Vikram Sarabhai also to have a discussion on the space program. And the InfoSpot was formed in 62. And they, of course, Vikram Sarabhai was made the chairman. And he inaugurated the InfoSpot. The
famous photograph, you kept it all over. The one where they are looking at on the right.
Yeah, that's
Of course, yeah.
There was no money for space research. But when it came under DAE, they made some revisions and they asked for money for the space research. And here he is saying that in a country like India, at that time also this question is still relevant, that whether we should invest in space research or not. So here he is saying, of course, yes. And why we should invest in space research on communication, for weather, for television, or even for other experiments. So this is what he is writing. And this, of course, is Mahan, Sarabhai,
Their thoughts mirrored each other so well.
Yeah,
They
exactly.
work together, really the composite outcome of their brains.
And here, he writes to Baba, and he is talking about the UK Space Research Committee. He has been there. He's trying to get help from there. Whereas Baba is talking NASA, and he is trying to get. So the two giants are trying to get information about both the things. And then for the Coast Guard, when Coast Guard was formed, the Coast Guard meeting becomes Sarabhai writes about what is the plan for India's space program, and he says that we want to have rockets and all that. Then, of course, this is a letter which Sarabhai writes in 1962. He says that they are going to check the site for Thumba. And
Yeah, I have seen this in Sarabhai as one of the songs. He said that he loved, Baba loved the area, the beauty of the ecosystem.
Yeah, and here there is a letter which Sarabhai says that there is some discomfort among the local people because it was a church and the graveyard. So
The church.
Yeah, church and the graveyard. But he said that no, the people can come and do prayers here when the rocket launching is not happening, and people can come to the graveyard to put flowers when the rocket launching is not happening till they have a new church.
Okay.
So that is there. This is the letter that we. Then of course about Thumba and all that. I think the graveyard is.
Oh, okay. It's very good.
Yeah.
Of course.
And after the Chandrayaan 3, the church community there celebrated the success of this and saying that it originated from here, from our community. Yeah, and this is all about Dr. Kalam, his recruitment time. This is his personal data that we have here. Then, of course, this was the advertisement that was given. Then here, here becomes Sarabhai's telegram saying that Dr. Abdul Kalam first choice. Then here, of course, Murthy, he is writing that as per it is requested the appointment of Mr. Kalam as rocket engineer for INCOSPAR be finalized and immediate arrangements are made to send him to Wallops for training. Kindly ascertain acceptance of the offer by Mr. Kalam and the date of his readiness to proceed here and let me know. And
Dr. Kalam had once come here to give the foundation. And he said, and I could answer. If he never asked me, I could answer. I would get the job.
So the committee which interviewed him had become such and this was such a development laboratory saying that I am here. He will come and join about the passport he has to US for training. And we as a president. This was in this launching from Thumba. This is a telegram saying it will be on 21st. First, he is writing it will be on 19th. But please, he's asking INCOSPAR members to stay back because the weather might not be good. But actually, it happened on 21st.
Okay.
And Then here they are discussing about the beginning of the space technology center. So what are things they want to do, how are they want to shape up that whole thing. So the entire discussion here in the letter, Vikram Sarabhai writing to Professor Mahan, is about how they are going to structure it, structure the whole thing. This is very interesting. There is a clipping from Times of India where they are saying Japan is helping Pakistan have a rocket launching station. So there is a first part as a sequel. So they want to
Not clearly identify.
TIFR then the balloon slides, all the things that happened. Bernard Peters, under his leadership, the balloon slides things happened. And then there is a lot of discussion about this Hava and Sarabhai meeting the people from Russia for the help. And you know how they are trying to get the Soviet Union helping them to. Here
The balloons.
Electronic. Yeah. People like sent from here, like Mr. Kalia, then Mr. Ahmed, Muhammad Ahmed, then J.T. George, they all from TIFR went to work in Cuba. Then this RF mass spectrometer experiment under the Buckley, that was there at the because of the balloons. And then this project Rohini in Salet. And how society and he personally set up the committee. Always there in the committee to do the people. He was always there and he was always that is something. Space center, then Professor was appointed as a consultant. So that discussion is also there, which have the letters. Yes, he gave a lot of support in the rocket. Then, of course, the first told Mama passed away. And everything changed. Vikram Sarabhai took over as the chairman of BAE. And then and the space program, Harish under Vikram Sarabhai's leadership, Professor Mahan took over as the director of TIFR. There was a very good understanding between them, which continued throughout as long as they lived. And here they are talking about this television, setting up this television satellite program. Then this is the dedication of Tumba to the UN as an international facility. Indira Gandhi coming here. Vikram Sarabhai is requesting Professor Mahan to come and be a part of the ceremony. Here, the astronauts visited TIFR in 1969. Apollo 11 astronauts. And they chose Mumbai, not Delhi. Then, of course, Delhi was a bit unhappy by Mumbai. But Indira Gandhi personally has wanted Professor Vikram Sarabhai, but he was supposed to travel. And that we see that both of them are. So these are all have some there. Then of the second passing away of changed quite a bit. And here was founding chairman of the and with the after the we can sort of the department right in the beginning, they will this pass their contributions. People in TIFR. He got these are very interesting letters. He was Professor Shikandar was invited to see the launch of Arya. He went. Management board.
Obviously, Dhawan himself was the chairman.
Yes.
So only board in the ISRO ever in the history the chairman chaired, and that was only. And he said this should not be a legacy for us.
So here, Professor Sikandar writes that the only time in my life when I experienced a similar thrill and a sense of achievement for the country was in 1956 when Apsara reactor went critical. After seeing the Aryabhat this thing. And here also it's a very nice letter from Satish Dhawan. He is saying that thank you, TIFR has been the cradle of India's scientific renaissance in the practical way. May I, on behalf of myself and my colleague in ISRO, convey to you and your colleagues in TIFR our grateful thanks for the contribution you have made, not only to this project, but to our whole program.
Oh, beautiful, beautiful. This is typical of Professor Dhawan, very expressive.
This is all about astrophysics. We at TIFR, we are all very proud of it. And
Great job. Fantastic.
you have been the
I know, because of that I know what you have.
present. There are lots
Hello, hello. A very warm welcome to you all to the Founders Day 2023 program. I'm Sana Sheikh, and I'll be your host this afternoon. It's my pleasure to also extend a very warm welcome to our online audience who is joining us live via Zoom and on our YouTube webcast. Your presence is truly appreciated. Before we begin, I request everyone to put their mobile phones on silent mode, please. Thank you. I now invite Professor Basudev Dasgupta, convener of this year's Founders Day program, to formally welcome everyone.
TIFR Director Professor Chingalu, Registrar Colonel Anand, Center Directors, Deans, Department Chairs, Section Heads, esteemed academic colleagues, non-academic colleagues, students, members of the alumni, and my dear friends. As convener of the Founders Day 2023, it is my pleasure to welcome you all. This year, we are honored to have as our chief guest, Dr. Kasturirangan, a luminary in the fields of science, technology, and education. Among his numerous achievements, which I will not list, let me only mention that he headed ISRO between the years 1994 and 2003, which is when the planning for the first Chandrayaan mission started. He is also an architect of the NEP 2020 policy, and he's a longtime friend of TIFR and a member of our council. Thank you for being with us today. We're really pleased to have you here. Thank you. Today we mark Dr. Bhabha's 114th birth anniversary. Each year on this day, we celebrate Homi Bhabha's multifaceted life through sports events, cultural activities, and scientific talks. In addition, we have the much awaited awarding of academic degrees and commendations, both for academics and for our non-academic staff. We have a really rich program ahead of us today, and without taking any further of your time, I welcome you all again, and I hope you enjoy your afternoon with us. Welcome.
I now invite the chief guest, Dr. Kasturirangan, the director, Professor Chenglur, and the registrar, retired Colonel Rajiv Anand, to join us on stage. As we all know, each year on 30th October, we commemorate the birth anniversary of a visionary scientist, Dr. Homi Jahangir Bhabha, the founder director of TIFR. As a mark of our respect, I request Dr. Kasturirangan and Professor Chenglur to garland the photograph of Dr. Bhabha. Thank you, sirs. I now invite our registrar, retired Colonel Rajiv Anand, to say a few words.
Dr. Kasturirangan, our esteemed chief guest for the occasion, Dr. Chengalu, other distinguished guests, and all the past and present staff members who joined us online or in person. It is indeed a matter of great privilege for me to be called upon as the registrar of the institute to speak on this occasion. But I must confess that being the only non-scientist among today's speakers, it is with a bit of trepidation that I step to the mic to talk to you with some very eminent members of the scientific community amongst us about another great scientist, the founder of our institute, Dr. Bhava. But of course, Dr. Bhava was many things besides being an eminent scientist. And here I would like to quote Dr. Julian Huxley, the British evolutionary biologist. He wrote a letter to Dr. Bhava when he was Director General of UNESCO to persuade Dr. Bhava to be available, to make himself available to be the next Director General of UNESCO. And in that letter, Huxley refers to Bhava not just as an eminent scientist, but as a person with experience of administration, an artist with deep knowledge and appreciation of the art, a person with experience of administration, and someone who was at home equally in the West and in the East. And as eloquent and apt as his description is of Bhava, it makes only a passing reference to him as an administrator. And that is the facet of his personality to which I seek to invite your attention over the next few minutes. Bhava's vision for TIFR was to build an institution that provided the kind of intellectually free atmosphere which in those days was only available at Cambridge or Paris. And he very clearly appreciated that for his vision to be realized and sustained, the institute must have a distinct style of administration. He himself articulated that the type of administration required for science and technology is different from the type of administration required for the operation of an industrial enterprise or the type of administration required for other fields. And at TIFR, Bhava developed and honed the style of administration. And he contributed to the growth of science and technology in the country, not just by forming and founding institutes like TIFR and the many others which were scheduled here. We are well familiar with those details. But he introduced this style of science administration, which inspired the later generation of scientists like M.G.K. Menon, Satish Dhawan, Raja Ramanna, and many others, to transform themselves from being scientists to become scientist administrators. And therefore, when we remember Bhava today as an eminent scientist and an institution builder, we should also acknowledge him as a very effective administrator and renew our commitment to uphold and carry forward his legacy. For in the words of Sir J.R.D. Tata, this institute's task will never end, but the frontiers of knowledge will always lie ahead. Before I close, I would like to thank Professor Basudev Das Gupta, convener of the Founders Day Committee, and his team for the stupendous efforts in organizing this event. Congratulations to all those who are being felicitated today. And I would also like to thank all the superannuating staff members for their service to the institute and wish them and their families the very best in the future endeavors. Thank you. Jai Hind.
Thank you, sir. Now I request our director, Professor Jairam Chenglur, to address the audience.
Thank you. I'll be brief. So I'd just like to take this opportunity to also extend my welcome to all of you for this Founders Day ceremony. Today, of course, as we all know, marks the 114th birth anniversary of the founder of our institute, Dr. Homi Bhabha. And, I think I'd like to thank Rajiv Anand also for reminding us of what a multifaceted person he was. In keeping with this, I think the Founders Days Committee has put together a very interesting program, not just for today, but also other events spread through the week. And we also have this very fascinating exhibition that the archive section has put together about DAE, TIFR, and the start of the space program in India. In that exhibition, which was just inaugurated by Dr. Kasturirangan, and we are very grateful to him for having kindly graced this occasion and having inaugurated that exhibition. I can think of no better person to have done that. Dr. Kasturirangan will also share his thoughts with us about this in a short while, and I really do look forward to that in a few minutes. There's also this art and photography exhibition in the foyer by our students. I just had a quick glimpse at it as I was going through, but it really looked beautiful, and I'm sure all of you would also enjoy going through it. We'll also be recognizing people today, both for, for their special services and also for people who put 25 years in our institution, building it up, contributing to it. So I'd like to express my gratitude to all of them. It's because of their work, their dedication, that TIFR remains what it is today. And I also, of course, congratulate all of them as well as our students who will be honored shortly. So that's about all I wanted to say. Once again, welcome to today's program. Thank you.
Thank you, sir. It is now our pleasure to welcome our chief guest, Dr. Kasturirangan, to share his valuable thoughts with us.
At the outset, let me thank Dr. Jairam Chandru for giving me this great privilege of being with all of you today afternoon on this Foundation Day, the birthday of Homi J. Bhabha, the legendary figure that gave India the strength in scientific research like nobody could do in the recent past, and also got the privilege of looking at the exhibition, which really says quite a lot about what had happened over the years since first the space was conceived, the mind of Homi J. Bhabha, and also shared with his very close colleague, Dr. Vikram Sarabhai. And when I went through this exhibition, which has been so well put together by Andrila Rai Chaudhary, I should say that it is quite revealing. There are many things. I try to find out these kind of things in the available literature, but something which is very original, probably it's only available in the archives of TIFR, many of them. So I could learn quite a lot by spending 15-20 minutes at the exhibition. And so that really gives a glimpse of the type of thoughts that went into the Bhabha's mind and the kind of things that we should start once the Sputnik was launched in Soviet Union and the 1957 heralded a program of space, accessing space for the first time by the humankind. So here was a visionary who also shared this with the other equally great visionary, Dr. Vikram Sarabhai. Between them, they conceived and gave a direction, a vision first and their direction for this program. Bhabha bringing together his extraordinary way of looking at things which are very much applicable to India, whether it is the three-phase program in the case of energy production with the nuclear program, which today is one of the important aspects of the India's nuclear energy program, or to look at the case of space and look at it as one of the most important and critical vantage point for doing work with respect to developing the humanity in a variety of ways, whether it's remote sensing, whether it is communications, whether it's meteorology, and whether it is related to scientific research, whether it is in trying to find out the Earth and its environment, the solar system, and the whole gamut of astronomy that it opens up. So this was the kind of a thing. So I got many of it even by just going through this in the last 15 minutes, but there is no better way for me to start this address than to recall Sarabhai's speech. He gave the speech on February 2nd, 1968 at the dedication ceremony of the Equatorial Rocket Launching Station at Tumba. You know that that's the southernmost tip of the country. The geomagnetic equation passes through it. It triggers a number of physical phenomena at the atmosphere as well as in the ionosphere. So there is tremendous scientific interest in exploring this part of the atmosphere and ionosphere over the geomagnetic equator. Sarabhai said, I may mention, was made the first time, about Sarabhai himself, he was made the first chairman of the Indian National Committee for Space Research in Coast Guard, the apex body to conduct India's space program. On the speech at that particular occasion, Sarabhai, while he lamented the absence of Dr. Homi Bhabha on that very important occasion, recalled his vision, Homi Bhabha's, that he recognized the great importance of advanced technology that atomic energy, space, and electronics represent. These are the three areas he had singled out as very important for India's development in the coming years. And he observed, he gave these three as a very specific to how the India's underwater technology could be developed using these, with of course its own applications and other kinds of advantages that they will provide. I would like to elaborate this a little on this. In 1961, the subject of outer space for peaceful purposes was allocated to the Department of Atomic Energy. Soon thereafter, the Indian National Committee for Space Research was formed. Quite early, the committee recognized that we have to establish a rounding rocket region for the reasons that I mentioned over the equator, geometric equator at Tumba, and they called us, as I said, laying foundation on trying to understand the atmosphere better, importance of meteorology being one of the considerations, and also its implications with agriculture, economy, and things of that kind. So the whole chain of thought that came in with respect to establishing this particular facility at Tumba was there very much in the mind of Sarabhai when it was trying to create, and of course inspired by Baba's own ideas on this matter. Even the laboratories related to the Department of Atomic Energy and largely supported by the department, because as I was told here, that obviously there was problems of funding, there was inadequate funding. So Department of Atomic Energy supported the physical research laboratory at Ahmedabad, where Sarabhai was there, and they conducted research, basic research in the fields of astronomy, cosmic rays, interplanetary space, and solar activity. The major responsibility for setting up the new activity, in consequence, naturally fell on the scientific personnel of the physical research laboratory. And in October 1963, the administrative charge of the Tumba establishment was formally entrusted to the physical research laboratory under Dr. Sarabhai's direction. I want to say this important decision that has been made of transferring the department, the job of the atomic energy on running the space program to the physical research laboratory where Dr. Sarabhai himself was in charge. And I may say this in this connection, through this Dr. Baba followed a precedent which had worked very successfully in the early stages of the atomic energy program, when the Tata Institute of Fundamental Research made a major role in establishing the atomic energy department. So he draws the parallel between that and the physical research laboratory being now entrusted with the space program being developed. The sounding rocket program was initiated by collaboration agreements with NASA, USA, France, CNES, Hydrometeorological Services of the Soviet Union, and so on. And in this ongoing rocket, the government and Sarabhai made sure that we have an agreement which we concluded with Centaur production. And this production of Centaur, the capability was identified with respect to the Baba Atomic Research Center at that particular time. So the initial production of Centaur, one of the key sounding rockets used in the subsequent experiments, especially in areas like sodium vapor releases in the upper atmosphere to look at the dynamics of the neutral atmosphere, neutral winds, and so on, were all done in the first rocket that came out of the production from the Baba Atomic Research Center, even though later on it got transferred to one of the ISRO establishments in the later phase. In 1966, the Atomic Energy Commission approved the establishment of the Space Science and Technology Center, now we call it Vikram Sarabhai Space Center, with the major task of developing expertise in aerospace engineering, sounding rocket of superior performance, and a modest satellite technology. The center was also concerned with the ground-based experiment, supporting space research and scientific payload construction. The first Rohini rocket, the Indian version of the sounding rocket, RH-75, was successfully flight tested since 1967, based on the work that has been done at the initial the Space Science and Technology Center earlier, and currently, of course, the Vikram Sarabhai Space Center. As an early part of this linkage, I want to recall two important developments with respect to the work in the Atomic Energy Department of Space, Tata Institute, with implication to the India space program. One, of course, is the question of developing the high-altitude balloons. These high-altitude balloons were the key elements to doing quite a lot of work which is related to the space science, whether it is on cosmic rays cosmic ray, electrons, then astronomy, particularly earlier places it will be X-ray astronomy, and subsequently gamma ray astronomy, infrared astronomy, and so on. So it became a very important vehicle for conducting space research, but within the atmospheric domain. The other aspect was to create a radio astronomical telescope to look at the skies with respect to the radio astronomical phenomena. And this was kept up at SUTI. And there is another thing, it had a lot of implication with respect to understanding the on-the-ground-based astronomical observation to many aspects of what goes on in the space. So these were very important precursors to doing things in space, because we wanted to, on one side, make observations of the objects which can be done with the ground with OT kind of telescopes, and on the other side, to evaluate concept and also to give the first level contributions by flying instruments in the balloon with it. X-ray astronomy. We had this both from the space as well as the Tata Institute as well as from the physical research laboratory, looking at individual sources like the score, the signals, and so on, and also to look at the cosmic background radiation and the X-ray wavelengths. There's the other part of it. So, and then of course there were also the gamma ray studies and the high energy particle studies and so on. So these were all part of the initial efforts to establish yourself as one of the key workers in this area, and also to develop the instrumentation which can be finally adopted for space-based mission. So these early efforts in space-related activities in atomic energy and also at TIFR give extraordinary impetus to undertake major space science programs. The first of which, of course, if I say, was the IRS PX3 mission. And later on, and why I'm saying this is, there was one of the time when large area proportional counters were flown. They were developed at the Tata Institute. Here, they were flown, and the first level of very good instrumentation and that was found in this to be found effective in trying to look at the observations areas like scope, signals, and Hercules, and things like that, and even looking at the question of mechanization of matter into the even horizon of black hole. There are indications that this particular instrument provided. So this is a very significant first step in trying to make a space-based X-ray observation. And this gave birth to the concepts that finally led to the definition of what we today call the AstroSat. AstroSat was conceived as a multi-wavelength observatory. The idea of making it a multi-wavelength observatory was primarily because of the fact that single point observations, increasing the sensitivity, increasing the spatial resolution and things like that, and making the instrument more and more sophisticated and size also was not something that was something akin to the kind of capability we had at a particular time. But nevertheless, astronomers at TIFR and some other astronomers in other parts of the country felt that there could be very interesting solutions to doing meaningful X-ray astronomy work by doing going for a multi-wavelength kind of a characteristic. And that was born the AstroSat. The importance of AstroSat vis-a-vis the work that we work together, the space and the atomic energy, and particularly TIFR, is the majority of the instrumentation that were to go in the AstroSat, which is the large area proportional counter, would be like 8,000 square centimeters kind of an area, with a soft X-ray telescope, a kind of a gazing incident telescope, Volger telescope. There is another thing. A cadmium telluride, zinc telluride, what do you call it? Gamma ray detection at the lower energy. These were all made by the Tata Institute. They made a proposal. When this proposal was considered, after the good assessment was made of the totality of what the mission should be like, we found that it's important that these instruments are developed. It's going to take time. So even as the project was taking shape, it was decided that a major chunk of funding is provided to the Institute to make sure that the initial steps of building these instruments, demonstrating their capability, and also their functionality vis-a-vis the use in space was all to be evaluated. The next few years, the work in Tata Institute mainly concentrated on these three instruments and became a key part of the AstroSat observatory capability, which today also after several years is continuing to provide very meaningful observations and excellent physics. These early efforts I should also say around this time, even though the lunar things were just coming up, Tata Institute had a very early pioneering effort in this. I remember this because Devendra Lal was one of the first to get the lunar samples. And he got to Tata Institute, the first lunar samples in the American mission. He did lunar sample analysis. And he was working, of course, on areas like archaeology of space objects, how the various kinds of particles impinge the space objects and what kind of imprints they leave. So these kinds of Professor Lal's work in that area, and followed by the work related to the use of these lunar samples to look at many aspects of the lunar legodit and other kinds of things, was a very significant first step in the context of the lunar studies that this country undertook, even as we started conceptualizing the lunar missions itself. I should remember in this that the X-ray astronomy and the early work of lunar of Professor Lal, the X-ray astronomy was I should say, was really facilitated by Professor B.B. Srikantan, who was there at MIT. In fact, I understand that he was working with Professor Bruno Rossi on the high energy part of it, particles. And there was this discovery by Riccardo Giovanni and his people. And Sarabhai happened to be there at MIT at the same time. So he asked Srikantan, who was there, well, why don't you look at this aspect and why don't we start something of this kind of thing back in the country? And it was Srikantan who worked with Minoru Oda, in fact, looking at the size of the object, X-ray emitting source of the X-ray, so along with it, there's a very seminal paper on that. And Srikantan got the field of the X-ray astronomy, and when he came back here, the X-ray astronomy in Tata Institute was started. Balloon-based systems were built, and that became a very case, not only producing very good scientific results, but also became a very good basis for carrying out the AstroSat mission in terms of the experience gained from these early things. All I know right now is that TIFR is now building many new areas and also trying to rebuild systems which have been modified in the context of changing times. And this will carry out more innovative and path-breaking missions of the nation in future, in which ISRO has made certain announcement that this has been out of date with Tata Institute in trying to bring in a more scientific basis for this kind of a mission. I should not also leave out the possibility of forays into the planetary exploration, as well as taking advantage of the major stride that India's space program has got, known a multi-dimensional lunar exploration. I'm not sure whether it is there very much in the recording of the TIFR thing, but I am sure knowing the past heritage and the kind of thoughts that have gone into it whenever new directions are put, I am sure that the Tata Institute will not be left behind in the lunar exploration, the planetary exploration, and most importantly also to look at areas like planetary systems on other stars, and on which you do our theoretical work now, but mere observational work also could be there. Of course, in all these, we had also a lot of interesting linkages. We had Professor Yashpal, who became from here the director of the space applications center in drove the space, and he also became the president of the International Space Conference. Professor Devendra Lal left TIFR, took over as the director of the BRL for quite some time. Dr. George Joseph is a legendary figure in building camera systems for the space, in fact, the space optics, and the kind of leadership that we have in the remote sensing center systems primarily comes because of the leadership that is given by Professor George Joseph. So there are many such instances of the human resource, extraordinary human resource that TIFR and Atomic Energy have produced, who have also moved to ISRO and created new niche areas and provided a leadership to the world in this area, in this kind of a thing, like the one that I mentioned about George's contribution to the remote sensing things. I would like to now say the other side of it. I've got quite a lot about TIFR, but it's more than TIFR. Our collaboration between space and atomic energy, of course, it also goes into areas in Bharat and many other places. To say a few things on these matters, I want to say that the early development of computer systems in the BARC, and we were quite interested at those times to look at the thermal analysis, structural analysis, and things of that kind. So the developments of TIFR, the computer system at BARC, these were things and tools that were used for initial modeling, simulation of structural and thermal systems for rockets and satellites. It was one of the major early work. Of course, we moved over to other types of systems, but these early impetus we got from the developments on computer sciences from here. The other aspect, of course, is space qualified photovoltaic system. We were able to create the photovoltaic systems, and atomic energy program did have some in the part of the photovoltaic. The developments, we did work very closely with them on this particular thing, and there were other questions of qualification and so on at the level of space. But then this was another major effort. Then we wanted to simulate. The other important thing is with respect to the simulation, the re-entry systems undergo very high temperatures, more than 2000 degrees Kelvin and even more. So how do you create evaluation and testing of this kind of a system? And we need to create plasma of high temperature. And here again, the Tata Institute, the Atomic Energy and IPR came together in developing those simulators with high temperature plasmas. And even today, one of the central piece of testing instrument that is there at Thiruvananthapuram is coming out of the developments of this kind of a thing. And I'm sure it's going to be even more work about it as the re-entry of the humans will come into picture with the new areas. And this is another area which I would like to especially recall. The nuclear power sources is another thing, whether it is nuclear isotopic systems or thermopile system. We need it in the case of where you can't use the solar cells, and also you need fairly large areas. And also with the advent of now the planetary exploration programs and the long-term things where you need the power even well beyond the solar influences in a substantial way. Nuclear power sources are going to be playing a very important role. I'm sure that the ISRO and the atomic energy will work together in the development of these kind of nuclear power sources, which will be used not only for remote sensing, for synthetic aperture radar, and that kind of microwave system, but also for the newly emerging planetary exploration. One of the specific things I would like to say, and this is very important in this occasion to mention, is the need to develop methodologies for rotor dynamics. We have to develop the gyroscopes, which are a kind of an inertial navigation system part of it. And we need highly rotating systems in these magnetic systems. And they were in the range of 4,000 to 5,000 RPM. The atomic energy's capability in this high-speed rotation is one of the things that we made use of in developing successfully the inertial navigation system involving drive-tuned gyros. This high-speed rotation and the dynamics related to the high-speed rotation was one of the major things. This became even more compounded as a challenge, technological challenge, when we had to develop the cryogenic engine. You know, cryogenic engine uses turbo pumps, which uses hydrogen and oxygen. And you have to pump in the best of circumstances, things like 2 kilograms per second kind of hydrogen you have to pump in. And for that, you need extremely high speed pumps of the order of 40,000 to 60,000 RPM. And that leads to a lot of instabilities in the rotation. I mean, you have an instability, you need to bring in the question of understanding what are those critical speeds where these instabilities develop and how do you deal with them. That's one of the capability. And there's another area where the atomic energy and the Department of Space work together, and particularly the BARC scientists come out with really unique solutions in addressing the questions of high-speed rotor systems. And this we want to recognize on this day because today some of the best rockets are powered by cryogenic engines. These cryogenic engines, that means essentially liquid oxygen, liquid hydrogen, and the kind of turbopumps that are used, uses technologies in which BARC had a very significant role to play. Now, I want to also say about the Electronic Corporation. They have virtually set up many space-based, the ground-based systems for space communication. Various types of electronic systems have been done. So what does it all mean? There's a fundamental technology. There's a tremendous breadth of various areas that these institutions have created. We, over years, ISRO has come out with many solutions with working closely with both the atomic energy and the TIFR, besides TIFR contributing fundamentally to various science missions, and these will all going to be taken forward. What I said is only a very small portion of the kind of depth and breadth in which the collaboration has gone. And now we have a major vision with respect to space, which is putting the man in the space, going and landing on the moon, return samples from the moon, and then using moon as a point for other planetary exploration and things of that kind. Our Prime Minister has laid out with time frames on these kind of things. What does it all mean? There is going to be a tremendous amount of technological challenges. There are the materials, environmental control, systems engineering, modeling and simulation, specialized electronic systems are some of the very interesting part of it. On the other side, there are interesting problems related to space medicine and the behavior of humans under the microgravity conditions. Both at TIFR and at the bar, there are people who can work on the space medicine related thing because of their background, the related areas of the life sciences. And this is just kind of thing that has happened, a flavor of what could happen, and areas of artificial intelligence, machine intelligence, and so on. I think there is going to be a lot of demands because the planetary exploration, you deal with long time for the transmission of signals. So you need to take onboard decisions. And so those kind of a thing. And atomic energy and space, DAFR has got its own strength in this area. And going to be another area which we have tremendous possibility of good collaboration. And so at this particular stage, we can develop these and use the models already developed successfully, and we also create more innovative methods of doing it. The two visionaries who give India the way to move the areas of atomic energy and space truly have become a pride of our nation in terms of these various activities. On this day, we remember with deep feelings and respect Dr. Homi Bhabha for his pioneering thoughts, ideas, and initiatives. Sarabhai, as his illustrious colleague, took space to its present praiseworthy level through his vision and missions, which I do not have to further elaborate. With such a bright future, the new generation has very exciting and challenging task ahead. I wish both these institutions the very best on their own and within the cooperative framework to strengthen each other's capability. I greet the Tata Institute and Atomic Energy on this Foundation Day and wish the very best. Thank you very much.
Thank you, Dr. Kasturirangan, for those insightful remarks. I would request our director and registrar to kindly present our chief guest with a token of our appreciation.
Thank you, sir. I now invite Professor Basudev Dasgupta, the convener of this year's Founders Day program, to introduce today's speaker.
Professor Mahan Maharaj is a mathematician at TIFR and a monk of the Ramakrishna order. He completed his integrated MSc from IIT Kanpur in 1992, and he earned his doctorate from the University of California at Berkeley in the year 1997 under the supervision of Professor Andrew Cazzo. After stints at IMSc in Chennai and at the Ramakrishna Mission Vivekananda University in Belur, he joined TIFR in 2015 as a professor. He has made noteworthy contributions in hyperbolic geometry, in low-dimensional topology, geometric group theory, and in the area of complex geometry. His work is considered a major milestone, and this is considered a major milestone in Thurston's program, which was initiated almost 40 years ago. In 2011, he was awarded the prestigious Shanti Swarup Bhatnagar Award. And in 2015, the very prestigious Infosys Award for his work in the field of mathematical sciences. He was also an invited speaker at the International Congress of Mathematicians in 2018, which was held in Rio. This is a major recognition for mathematicians. So with these few words, I would like all of you to join me in welcoming Professor Mahan Maharaj to deliver today's public lecture.
Share the content. Share content. Look.
Yes.
Right. So, thanks very much, Basu, for this very kind introduction. Professor Kasturirangan, Professor Chengulu, friends, colleagues. So, yeah. So, here's the point of this talk. What we are basically going to try to illustrate is that the subject geometry, which we start learning in school and often forget subsequently, is something that's really quite ubiquitous. And one bit of yes. Yeah, okay. So fine. So what we usually, I mean, one of the things that हम लोग को समझाते हैं कि बस ये 1, 2, 3 dimensions, ये जो space we live in is all that there is. तो आखिर में हम कोशिश करेंगे कि इसके बारे आगे भी कोई ज्योमेट्री बसता है, मगर वो बस ये बस नहीं है. अच्छा, तो ठीक है, तो चालू करते हैं अभी. लेट्स सी. तो बच्चों जब लकीरें खींचते हैं तो ऐसे फिगर is as in this first diagram right here. This is a kind of diagrams that children start making. This is in terms of matchsticks. So ये भी geometry है. And this is not supposed to be an advertisement of any particular company, but you'll see this kind of stuff that's made, and children do start with such figures. So फिर जो जब बड़े हो जाते हैं तो ऐसे लकीरें खींचते हैं. ठीक है. So and underlying all this, I mean, in the previous page and on this page, figures you see, the question that we'll be trying to address is इतने सारे range जो है, इसमें कुछ सामान्य कुछ है क्या? Is there something common between these children's diagrams and this bridge or whatever, the ceiling here? That's one question that we'll start to address. And so let's start with matchstick figures. Yeah? Let's start there and try to extract some features which, in spite of this large variety that we saw in the previous 2 slides, does feature fairly frequently. So in this one, imagine these red blobs here to be matchstick के head. And these black lines are the bodies of the matchstick itself. और फिर ये जो सफेद region जो है, that's the region between capped by various matchsticks. So ठीक है, let's just start with a simple count. How many match heads are there? How many red match heads are there? So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 match heads here. कितने matchstick है? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 sticks are there. And how many white regions are there? So मतलब ये region कितने हैं? 1, 2, 3, 4, 5, 6, 7, 8. So 8. But one of the points that I'll try to stress, ये विशेष जो नंबर है, ये बदलते जाएगा. मगर एक चीज नहीं बदलेगी, वो क्या है? So take the number of match heads, 9, number of matchsticks 16, number of regions 8, and do 9 minus 16 plus 8. Matlab, number of things which are like 0 minus number of things which are like 1, and then two-dimensional regions like that. Oops, what happened? यहाँ तो मैं कुछ नहीं किया था. Yeah, the problem with geometry is that you have to have pictures. I can't go on talking in the absence of the picture. Okay, fine.
Just check it.
No.
Now?
So 9 minus 16 plus 8 is equal to 1. 17 minus 16. So the way the mnemonic to remember this is that the number of 0 objects, that means count these blobs, red blobs, then count the number of 1, that means the sticks, the matchsticks, and then add number of regions. So you look at this number of zeros minus number of ones plus number of 2s. For this particular diagram, you added that up, we've gotten it to 1. Okay? So दूसरे figure पे भी यही चीज करते हैं. So now this is another matchstick figure, and I have been too lazy to color the inside regions white. So imagine that this parchment color in the inside is white, outside is still just a parchment color. So how many red blobs are there? Let's do the same experiment. So I'll have to. V.I. Arnold was a mathematician. He used to say that mathematics is that branch of science where experiments are cheapest. So see, these experiments, all that you require is just some counting. The experiments are done on pen and paper. So let's do this count. It's basically the same thing. We are just counting number of red blobs minus number of black sticks plus number of regions. So what is the number of red blobs? 1, 2, 3, 5. The outer rim has 5. Inside the next level, this is drawn a little asymmetrically. These edges should have been pointing a little inward. Anyway, there are 10 levels. So 1, 2, 3, 4, 5, 5 in the middle. So 5, 10 at the second level, and 5 in the middle. So there are 20 red blobs. So this is, now I've changed R, which was the notation for match heads, by a more frequently used symbol, B. Well, it's just a symbol, just a letter, call it what you like. Yeah. So there are 20 of these guys. How many matchsticks are there? 1, 2, 3, 4, 5. At the next level, 1, 2, 3, 4, 5. Next, there are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At the next level, there are 5. 1, 2, 3, 4, 5. Then again, there are 5. So how many is that in all? 5, 5, 10, 5, 5. So that's 30. Yeah? So number of sticks is 30. How about the number of regions? 1, 2, 3, 4, 5. Next, 1, 2, 3, 4, 5. And there's 1 in the middle. So 5 and 5, 10 and 1, 11. And so, what is this V minus E plus F? Matlab, how many blobs minus number of sticks plus number of regions? So number of 0-dimensional objects minus number of 1-dimensional objects plus number of 2-dimensional objects. इसी को हम गिन रहे हैं. तो कितना हो गया? 20 minus 30 plus 11. 31 minus 30 आ गया फिर से 1. तो प्रश्न ये है कि एक कोइंसिडेंस है क्या? तो चलिए एक रैंडम पिक्चर निकाल लेते हैं. So this is a map of Bombay. So here Bombay, with starting with the map of Bombay, can we construct this kind of a graph? Okay, let's do the same thing. Let's take the northern, so this is Bombay divided into its regions, right? So there's this northern region. Northern region is adjacent to east and west. So ये हर एक region के लिए एक blob दिखाते हैं. So there are 1, 2, 3, 4, 5, 6, 7, and so there's 1, 2, 3, 4, 5, 6, 7. So for each region, put in one little blob on your graph itself. So imagine that this yellow is actually red. So basically, the reason why I've chosen a color yellow for this is very low level, just to show the contrast between the background color and this blob. That's all. Yeah, so it doesn't matter if you think of this as red. It's not significant. Color coding is not significant. So how many sticks are there, and what is the rule for introducing sticks? The thing is, if you have two regions, two parts, say, so two of these regions, subdivisions of Bombay, which share a common boundary, you draw in an edge. Yeah? So the north and the west, they share this common boundary. So we put in an edge there. The north and the east also share this boundary. So we put in an edge. East and west share a boundary, put in an edge. And then go on doing the same thing, and you basically get this little graph out here. And so how many vertices are there? Just count 3 and to 5 and to 7. How many edges are there? That means how many boundaries are there? 1, 2, 3, 4, 5, 6, 7, 8. Edges are 8. Regions, there's just this one internal region and this one internal region. So that's 2. So what is V minus E plus F? 7 minus 8 is 2, 1. Now, obviously, there is something going on. Okay? And so this is basically, I mean, we just picked Bombay. Bombay is not particularly important here. You pick the map of India. It will be easier to do it with the map of US because US has vertical and horizontal boundaries. It will be pretty easy to do. And it will come up with the same thing. Yeah? So this is the place where this part, so essentially any map really works. So pick a graph, pick any map. Yes, so open a political map, and mathematics is basically very apolitical. It doesn't care if your political boundaries change, if you're working in 1800, you're working now. Yeah. So essentially do this V minus E plus F computation, and you're going to get 1. All right. So here's the thing. So that's one part of the story. So independent of what map you choose, you're going to get the same number, 1. All right. So this is basically one-dimensional diagrams in the two-dimensional plane where we start doing our school geometry. Let's move up 1 dimension each in terms of the object, which is going to be something that's 2-dimensional, and will be situated in 3-dimensional space. And our goal will be to find, again, something that is democratic, something that is invariant and does not discriminate between these various individual objects that we are looking at. Okay. So, but before that, we'll have to do a little bit of preliminary work, something that we know from school geometry, which is take any convex polygon. Yeah? Then the sum of the exterior angles, yeah, these are the exterior angles, that sum is 360 degrees. This is something we learn in school, and I'll just take this opportunity to give a quick proof of that. What you do is you take this polygon, move all the sides parallel to themselves, and they start shrinking. So basically imagine these sides moving. Finally, this whole polygon becomes this one little point there. And all these external angles are arranged around it. So the exterior angles here just get arranged to be all the angles around the circle. And so the sum of the exterior angles of any polygon, yeah, is 360 degrees. Yeah? This is basically a proof. Just remember. So this is one thing that we need to remember for going up 1 dimension. Okay. So this is exterior angles. Okay, fine. What about interior angles? So let's say equilateral triangle. Yeah? So that means the number of vertices here is 3. So at each vertex, you have external angle plus internal angle is equal to 180 degrees. Yeah? So if you have three vertices, total sum of internal and external angles is 3 into 180 degrees. And 2 into 180 degrees is eaten up by the external angles. That's what we've shown here already. So triangle ke liye bacha bas 3 minus 2 into 180, which is 180 degrees, jo hum sabko malum hai. This is some convoluted way of reducing the same thing. But it's basically taking this as the fundamental observation. External angle sum is 360 degrees. What is the internal angle? So for a triangle, it's 180 degrees, 1 into 180 degrees, where 1 is thought of as 3 minus 2, 3 being the number of vertices, and this 2 is something that is that you have to throw away as the sum of the exterior angles, whatever be the number of sides that you have. So what is the internal angle? 180 degree divided by 3 equal angle, so it's 60 degrees. Square, we all know the internal angle is 90 degrees, so we'll deduce this in this convoluted way again. So if there are 4 of these vertices, so that means total angle, internal plus external, will be 4 into 180 degrees. 2 into 180 degrees gets thrown away because of the external angles. Left is 2 into 180 degrees. 4 vertices divided, you get 9. And now we come to the first calculation, which is not there in, well, which we are not always familiar with at school level, which is a pentagon, which is exactly this figure. 5 vertices, total angle 5 into 180. Throw away 2 into 180 because of external angles, but 3 into 180, so itna hai, divide by 5, you get 108 degrees. And this thing goes on. You can look at polygons, convex polygons with n sides, and you're going to get this n minus 2 into 180 degrees as the internal sum, and you divide by n. That's not very important. We'll just be using equilateral triangle, square, pentagon. So if you want to take home anything from there, this internal angle of a regular pentagon is 180 degrees. That's all. Now let's use this to go to two-dimensional objects in three-dimensional space. So यहाँ कई सारे example बिठाया हुआ है. And our question is, so this here, this one is this, I'll have better pictures of this object a little later. It's called a tetrahedron. So 3 face है, सारे के सारे equilateral triangle है. This is a cube, something we are familiar with. This guy called a dodecagon, it's not a football. So there are 12 faces like this. The question that we are asking is, इसमें ज़्यादा नुकीला कौन सा है? Which one is sharper? Yeah? And of course, I mean, there's a very easy way to find out, somewhat painful way. Pick any of these up, but you can do it mentally. Pick one of these up, poke yourself with it. Which one hurts more? Yeah? And that's it. I mean, so which do you think amongst all these shapes, assuming there are, I mean, all these extraneous conditions about what material it is done, made up with, whether the machining is fine or not, forget all that stuff. Yeah. So yeah, mathematicians have this incorrigible habit of actually ignoring all the real phenomena and abstracting out something that most people are not bothered about. Jo bhi hai. So, isme, what is your guess? Is the tetrahedron sharper? Is a point of the cube sharper? Is a point of the dodecahedron sharper? So, ye prashna ko hum, iska, the next few slides, we will be trying to answer this question. Which should hurt you more if you poke yourself with it, and why? Yeah? And essentially, ये प्रश्न के आंसर देने के लिए पहले हमको समझना पड़ेगा कि इसमें बिल्कुल what is the zero level? Yeah? मतलब what is flattest? जिसमें कुछ भी there will be no feeling of any pain whatsoever, which will just come at something which is totally flat. And that is, see, basically, so our zero level is basically the flat plane. Look at this base. And we start, if we put our hand on it, there is no sharpness, no feeling of sharpness. So the zero level is fixed as the flat object. And a point which sits on a flat plane, uske charo aur angle kitna hai? So that's 360 degrees. So here we are, this is the first measure of sharpness at a point. Mathematicians have a name for it, which is not important. Just think sharpness at a point. How do we measure it? Just look at the difference between 360 degrees and the total angle there. This is our naive measure of sharpness at a point. And strangely, this very naive measure of sharpness at a point is remarkable in terms of how far we can run with it. So just look at this. So this is our, it's also called angle defect. 360 degrees minus the sum of the angles. If the total angle was 360 degrees, it would give 360 minus 360, 0. No sharpness, no pain. Yeah? So that's our starting point. Okay? So चालू करते हैं. Let's say this is a better picture of tetrahedron. 4 faces. एक face आपको दिख नहीं रहा है, वो पीछे है. 1, 2, 3, 4. Tetra means 4, so 4 faces. Each face is an equilateral triangle. Equilateral triangle, internal. अभी एक vertex को हम, I will focus on one vertex. Take this vertex here. So how many faces are there? 1, 2, 3. So angle कितना है? This is an equilateral triangle. So the angle here is 60 degrees. Angle here is 60 degrees. Angle here is 60 degrees. So total angle at a vertex is 180 degrees. So angle defect, measure of sharpness, कितना है? 360. Okay? This is the measure of sharpness that we had agreed on. So remove that. So remove this total sum from 360. So there's 180 degrees worth of curvature, worth sharpness concentrated at a vertex. And this vertex was not something particularly special. So sub-vertex पे इतना ही curvature concentrated है. Why? Because we have chosen a regular tetrahedron. So what is the total curvature? Now this is a computation which, I don't know, I mean, why would anybody want to do it? Let's just do it. Total sharpness of the whole object कितना है? Okay, at some point there's this sharpness, 180 degrees worth of curvature concentrated at a vertex. So कितने vertex है? 4 vertex है. Total curvature में total sharpness कितना है? मतलब if you take the sharpness of 4 places put together, how much will you get? 4 into 180, which is 720 degrees worth of sharpness is what we have in the tetrahedron. Okay, now let's do the same thing with a plane. How much is this? So you have one of these points. What is the angle here? 90 degrees. 3 faces total, 3 into 90 degrees, 270 degrees. So sharpness concentrated is 360 minus 270, which is 90 degrees worth of curvature. Which means that if you poke yourself with a square, it will hurt you less. It will hurt you half as much as if you poke yourself with a tetrahedron. Yeah? Where half is, this is the measure of, I'm pretty sure. I mean, again, you're completely ignoring the very relevant part of how our neurons fire, etc., etc. As I said, we completely ignore these actually sophisticated considerations and measure it, take this very naive measure. Yeah? So here you have sharpness at one of these vertices is 90 degrees. What is the total sharpness? So that means you just have to count the vertices. 1, 2, 3, 4, 5, 6, 7, 8. 8 into 90, 720 degrees worth of sharpness is there in the cube. All right. So let's take a sudden breath. So we'll do it for a dodecahedron, which is what? I mean, this is supposed to be the one thing that we did not know, pentagon. This is a shape which has 12 faces. Each face is a pentagon. Let's try to do it with this guy. Again, how many faces are there? 108, 108, 108, 324. Sharpness at a vertex is gone drastically down, almost to 1/3 from a square. So 3 into 108, which was 324. Sharpness at a vertex is 360 minus 324. That's 36. Now, how many vertices are there? So that's 36. So basically, again, something that we should have said immediately. Everybody knows. You take a tetrahedron, poke yourself, it's going to pain you more. Take a square, it will pain you less. Take something nice and round like the dodecahedron, it's going to pain you even less. But how much less? So this basically tells you that there's this 36 degrees worth of curvature, worth of sharpness concentrated at every vertex. Now what's the total then? 1, 2, 3, 4, 5. The next level, 1, 2, 3, 4, 5. Then these last guys, 1, 2, 3, 4, 5. And then this interval, 1, 2, 3, 4, 5. So this dodecahedron, which is one of the graphs I had drawn earlier, it has 20 vertices. So 36 into 20, 720 degrees again. So this is also, so we've done 3 experiments and we get this answer. So that basically prompts us to ask, is this a general phenomenon? Indeed it is. And the earlier thing, this number of vertices minus number of edges plus number of faces is equal to 1, is an experiment which was run and proved. It's called the Euler's formula. It's basically one of these formulae from which this field of geometry called topology starts. That was the 18th century. This gadget is the 19th century because it took 100 years to go up from 1 in 2 to 2 in 3. Yeah? So this is Gauss, is the person who basically set up the whole thing, 19th century, and then here Bonnet completed this. And here's the theorem. So when we have one of these things which holds in general, the mathematicians call it a theorem. Given any convex polyhedron, the sum of the sharpnesses, which is what we call mathematicians call curvature, as you sum it over all vertices, is always 720 degrees. And it does not, I mean, the earlier solids were regular solids, it doesn't matter. It's true for all irregular solids as well. So here's a hard take-home exercise. You take this gadget along, construct a model, do your angle sum computation, angle defect computation, sum the angle defects, and you're guaranteed to get 720 degrees. All right, fine. So took about 100 years to go from 1 in 2 to 2 in 3. How about still higher dimensions? And now we come to the 20th century. And so, and this is the only slide which is dedicated to the best. But it's not here. So, is there something along this slide, these lines in higher dimension? Indeed, yes. So, in honor of Euler, which is what this first V by E plus F was about, there's something called the Euler characteristic, and this holds in arbitrary dimensions. 3 पे बस करने का कोई जरूरत नहीं है, कोई भी डायमेंशन लगा वो this Euler characteristic goes through. क्या है मैं आज नहीं बताऊंगा. And the second theorem is 2 in 3, Gauss-Bonnet theorem, that does generalize, but this is basically middle of the 20th century. This theorem is basically the 20th century. So this is Gauss, this is Bonnet, and now there's this mathematician from Chern, who basically extended from dimensions 2 to 4, 6, 8, 10, all even numbers. 3 dimensions, they become the trivial formula, we ignore it. But Chern essentially extends that Gauss-Bonnet formula that the sum of the sharpnesses is equal to 720 degrees, but generalizes to all dimensions. And this is Chern. Okay, so what is the point of all this? And I'll try to conclude with an anecdote about Chern. But before that, let me just finish the mathematics. The point of this whole thing is, we start with children's quick toys, matchbox diagrams, or bridges. Start with any map you like, and go on to mathematical graphs or networks. If you want a unified picture, something that does not deal with the particulars of the situation, but gives you some picture, which is general to all of that. And then for 2 and 3, polyhedra and complex multidimensional shapes, in this field, geometry gives you a unified picture. So that's as far as the maths is concerned. But maths is done by mathematicians. And I just want to narrate this one story about Chern. So this was in my final year of grad school, and the Chinese students on campus had made this hall which was dedicated to Chern. And the first inaugural series of lectures was given by Chern then. Chern was actually a little older than Yuka at that point of time. He was about 85. And he started off by saying this, and this is a particular area of geometry which is called Riemannian geometry, where you have basically every point, there's a well-defined way of measuring both length and angle. There's a generalization of that, where angles do not make sense, but lengths still make sense. It's got a name, it's called peninsular geometry. The Chern, at the age of 85, he starts off by saying that, you see, I have spent all my life studying Riemannian geometry, I should have paid more attention to principal geometry. And he gives this collection of work, and that set of work becomes basically, it became a foundation piece of work, appeared in the top, definitely the top mathematical journals, and this foundational work. And today, if anybody does principal geometry, one goes back to this work of Chern, which was done at the age of 85. Yeah. So age is no restriction, age no doubt. Yeah. So thank you very much.
Thank you, Professor Mahan. If there's something that could have pulled us out of those technical failures and overrunning time, it's a marvelous lecture like this. We have time for a few questions. There's a mic downstairs. Please wait for a mic. Yeah. Thank you, Mahan, for the amazing talk. So I want to know, is it possible to define surface for a sphere, considering that a sphere is a infinite number of edges?
Good question. So here's the way you go about doing it. So you could take any polyhedral approximation to the sphere. And then what you do is, the following. You look at polyhedral approximation, and then for a thing which is infinitesimal, like the sphere, which is always smooth, it does not have vertices. You do an approximation argument, and then that actually assigns to you a way of assigning curvature at a point. But it's an infinitesimal quantity. So what you have to do, you have to integrate instead of just coming over finitely anything, and you do that. This is an alternate proof of the Gaussian for the sphere, and the same thing goes for it. Thank you. Yes, so the first linear graph that you showed, one could just prove that by induction. Well, so by the higher dimensional stuff, can you give us an intuition to how it would then go back to?
Okay. Start with any, so what's going on? So why would one imagine such a thing to be true? Yeah? Actually, I have pulled a bit of a fast one. Yeah? So the thing is, if you look at this V minus E plus F, yeah? And you take this sphere, all the surfaces of all the fellows I was drawing, yeah? Is actually a sphere, correct? If you remove a point and you flatten it, you are going to get a planar graph. The point is, for all these planar objects, this first theorem, V minus E plus F equal to 1, what you need to do is it's on a plane, you count the external face also, and you collapse it, you put one point in infinity and you collapse it down to a sphere. Then you are going to get V minus E plus F equal to 2 for any diagram on a sphere. The point is, if you do this angle sum business, then this Euler's formula, V minus E plus F equal to 2, is exactly the same as the Gauss-Bonnet theorem for this sphere. You just have to do one angle sum computation. That's all, nothing else. Really, the proof of that comes from, and so that's why it's the more sophisticated way of saying Gauss-Bonnet theorem is that it's 2 pi times the Euler characteristic. And this Euler characteristic is V minus E plus F, which is equal to 2. That's the connection between the first part of the second part. Okay, sorry if that was absent. Yeah.
Yeah, just making a comment about the connection between what you said and particle physics. So, as you know, exactly the same formula V minus E plus F comes in characterizing perturbation theory of gauge series, quantum Young-Mills series, that was shown by a Prof in the 70s, when you take Young-Mills series with a large number of colors. And the other things that you mentioned are the planar examples, planar diagrams. That becomes the most prominent one in the limit of large number of colors. But the non-planar guys also come in when you are more accurate. So if you want to do it for 3 colors, then you have to also look at non-planar guidelines. But indeed, exactly this counting, the V minus E plus F that appears in two. Yeah. So let me add to that 2 comments. First is slightly technical. So essentially, the bigger brother, the elder brother of this Gauss-Bonnet system is something called the Atiyah-Singer index theorem. Again, this holds in all even dimensions. And there is a free-string theory written proof of that from using supersymmetry. It is general principle going to data. Anyway, so basically, there is a way of looking at this one Gauss-Bonnet using supersymmetry also. That's one. And the second thing, I think this is the benefit. Basically, we divide science into different subjects basically because of our limitation of brain size. That's all. And there is no real benefit. Okay, thank you.
All right, I think maybe the last question to Cindy. Yeah.
It's clear why even in order different having to do with anomaly, causality, but what's the odd dimensional?
The odd dimensional version of this is free, basically because the odd dimensional Euler characteristic of any closed manifold is zero. That's
But there should be some, there's no universe especially in
I mean, you can do it. You're going to do it. Going to get the filling equation equal to zero. That's the point. So because it's because of this odd thing with transfer. So there's no nice generalization of this. However, okay, I have to okay, so this is meaning I'm getting technical basically means I don't understand it well enough. Okay, so there is a Stern-Simons version of this. It's also free. So you look at you take connection, you look at dA, reg A, and then there's another term, A reg A reg A. And then you integrate it out, you get the conformation then.
I think it's time for us to thank Professor Mahan again. Please give him a big round of applause. We'll have a short break right now and we'll reconvene in about 5 to 10 minutes. So let's say we start at 4 again. We're sorry for running a little bit over time, but we hope the program has been entertaining so far. Please join us at 4 o'clock.
Amish, can you hear me?
Yes, Bully.
Yeah, the YouTube thing, maybe there's some sort of clipping kind of things is happening. I think Vijay was mentioning. Even the settings seem okay, but just some volume, if you can adjust it properly. And if you can see on the YouTube, maybe it will be better.
Okay, Mrs. is calling you that you
sorry, slight change in events. I think we're taking a bit longer to get tea in the business cafe area. So I request all of you to go get a cup of tea and come back hopefully by 4:15, 4:20. We have another 10 minutes and start under 5 weeks at MKIT water session. Thank you.
Welcome back, everybody. May I request you to please put your phone on silent mode again. Thank you. We have now reached a much awaited part of this program, the academic commendation ceremony, where we recognize and honor the outstanding achievements, academic achievements of our students and teachers. Kindly join me in welcoming Professor Subha Tole, Dean, Graduate Studies, on stage. I request Professor Tole to recognize the students who have received the degree from TIFR in 2023. It is my great delight and privilege to announce the degree awardees of this year. In the year 2023, TIFR awarded 47 PhD degrees to students and 26 PhD and master's degrees to integrated PhD students, 1 MPhil degree and 33 MSc degrees. I will now read out the names. Much success and Godspeed to all our degree holders. PhD degree awardees in physics: Abhinav Sala, Animesh Nanda, Anurag Kaushal, Arnab Seth, Deepika, Prashant Singh, Pratap Chandra Adat, Saikat Karmarkar, Sandeep Mandal, Shilpa Sasikumar, Soumya Mukherjee, Suman Kundi, Sunil Kumar Sake, Vishnu Sethi. Integrated PhD students who received the PhD and Masters: Aditya Chaudhary, Anurag Tiwari, Akhidev Chatterjee, Harsh Jain, Mayank Naran, Ram Prasad Pandya, Kamal Ganesh Kashyap, Soumya Bhattacharya, Sudeep Chakraborty, Sunil Kumar Jaiswal, Vikas Jindal. The MPhil degree was awarded to Deepak Chandra Joshi. Master's degrees were awarded to Ranjan Sharma and Yogi Reddy Veerababu. From the subject board of chemistry, PhD degrees were awarded to Amitava Chandra, Anamika Biswar, Ankur Gupta, Arup Kundu, Mithilesh Kumar Nayak, Pallavi Thakur, Sabyasachi Chakraborty, Satyavrata Bandhopadhyay, Vicky, integrated PhD students who received the PhD and Master: Mohammad Tahir, from the subject board of biology, PhD degrees were awarded to Abrar Ahmed Bhatt, Amrita Vasudevan, Anjali Amelia Jaiman, Chaitra Prabhakara, Geetika Chauhan, Jagjeet Singh. It's always special when one knows these students personally.
Jyoti Venugopal Nair, Kirti Gupta, Komal Raina, Nitish Dua, P.S. Kesavan, Pankaj Kumar Chauhan. And Hani Shilpa Pothaprabodha, Priya Datta, Rishabh Mitra, Sahil Lal, Sunny Kataria, Umesh Mohan. Integrated PhD students who received the PhD and Master: Ankita Prakash Chodankar, Aparna Agarwal, Arpan Paicha, Pravanti Nadininti, Prachi Tiwari. And Rohit Dev, Sukita Arun Soman, Suhas Hemant Bhate, Vinaya Hemant Sahasrabuddhe. Master's degree in biology was awarded to Amartya Pradhan, Ankit Singh, Anusha Singh, Anushka Deb, Gaurav Bhardwaj. Himanshu, Rita Das, Sulekha Bhatt, Swapnali Patil, Varsha Mahapatra. MSc degrees in wildlife biology and conservation were awarded to Abhijit Akali Velam Veli, Arjun Shekumar Mani, Avantika Deep Sharma, Deepti Manohar Bajaj, Divya Jyoti Ganguly, Muhammad Naz, Shahid Ahmed, Muqaddam Wala, Niranjana Chetana, Nisha Bhakat. Preet Sharma, Priyanjana Pramani, Radhika Sunil Nair, Sanjeev Bania, Siddhi Jaisankar, Siddharth Srinivasan, Yashasvi Rao Ravipati, Yashendra Chinmayi Joshi. From the Subject Board of Mathematics, PhD degrees were awarded to Jitendra Rathore, Kohinoor Ghosh. Integrated PhD students who received the PhD and Master: Animesh Jana, Prahlad Kumar Sharma, Riju Saini, Somen Senapati, Utsav Sarkar. The Master's degree in Mathematics was awarded to Gitanj Dandona, Raftin Maskara, Shubham Belwal, Sudeep Shaw, Sumit Kumar Singh. From the Subject Board of Computer and Systems Science, the PhD degree was awarded to Subhada Agrawal, Tulsi Mohan Moli. From the Subject Board of Science Education, PhD was awarded to Himanshu Srivastava and Zeenat Rahman. And now we come to the best thesis commendations. All students who were awarded their PhD at the Academic Council meetings of August 2022 and February 2023 were eligible for the best thesis. February 2023 and August 2023 were eligible for the best thesis awards for this year. We are also announcing the best thesis awards of last year, February 2022 and August 2022. So I will do so in sequence. Okay. I will hand over to Sana for 2 minutes.
Thank you, ma'am. The TIFR Endowment Fund has been encouraging the TIFR community, especially students and teachers, by instituting commendations that recognize excellence in academic performance and teaching. To give away these honors, I request the director, Professor Chenglur, to please come back on stage. The recipients of these honors are present here, are requested to please come on my left-hand side and come up whenever their names are announced.
Okay. So it's with great delight that we are now able to announce the best thesis commendations, which we are going to announce for 2 years. Each subject board considers theses that are nominated for the years that are eligible. And depending on the number of theses submitted, either 1 or 2 best thesis awards may be given, in addition to an honorable mention or 2. The Geeta Udgaonkar Best Thesis Commendation in Physics for 2022 goes to Dr. Barnali Das. For discovering exotic electron cyclotron maser emission in more than a dozen magnetic massive stars. I hope Barnali is joining us on YouTube with family and friends. An honorable mention for physics into 2022 goes to Dr. Surajit Datta for elucidating novel electronic states that emerge in a two-dimensional type 2 superconductor in the presence of magnetic field. The Zita Lobo Memorial Best Thesis Commendation in Biology for 2022 goes to Dr. Anamika Sharma for her study on the cellular role of IP3 receptors in insect flight. The Best Thesis Commendation in Chemistry for 2022 goes to Dr. Tathagata Nandi for his investigations on the ubiquitin family proteins, elucidating the role of salt bridges in protein stability and folding. The Harish Chandra Memorial Best Thesis Commendation in Mathematics for 2022 goes to Dr. Mainak Ghosh for his thesis that has led to new directions in the geometric class field theory of singular varieties. An honorable mention for mathematics in 2022 goes to Dr. Mahbub Alam for interesting new results at the interface of ergodic theory on homogeneous spaces of Lie groups and Diophantine approximation. The Best Thesis Commendation in Science Education for 2022 is presented to Dr. Shirish Pathare, who is with us. Let me read the citation. For his substantial contribution to the understanding of alternative conceptions in elementary thermodynamics, which resulted in the inclusion of several experiments in the undergraduate physics curriculum. The Best Thesis Commendation in Computer and Systems Sciences for 2022 is presented to Dr. Siddharth Bhandari. For a breakthrough in a long-standing open problem on exact sampling of graph colorings. And now we move to 2023. The Geeta Udgaonkar Best Thesis Commendation in Physics for 2023 is presented to Dr. Aditya Chaudhary. For using deep observations with the upgraded GMRT to significantly advance our understanding of the evolution of the uptake and use of baryons in galaxies. The Geeta Udgaonkar Best Thesis Commendation in Physics 2023 is presented to Dr. Anupam Ray for his novel studies on dark matter capture in stars, transmuted black holes, and for new influential constraints on primordial black holes. The two advisors are standing right here. An honorable mention in physics in 2023 is presented to Dr. Pratap Chandra Adak for experimentally probing Berry curvature and magnetotransport studies on twisted double bilayer graphene in the Hofstadter regime. The Dr. Zita Lobo Memorial Best Thesis Commendation in Biology 2023 is presented to Dr. Chaitra Prabhakaran, whose father will receive the award on her behalf. We are delighted to welcome you, sir. The award is for her scholarly investigation in the mechanisms shaping morphogen gradients by receptor binding and uptake control. Dr. Zita Lobo Memorial Best Thesis Commendation in Biology 2023 is presented to Dr. Fani Shilpa Pothapragada for her research into the mechanisms of regulation and dysregulation during epithelial defense against cancer. An honorable mention for biology in 2023 is presented to Dr. Namrata Shukla for her study of biochemical and epigenetic control of nutrient-dependent signaling in physiology. The Best Thesis Commendation in Chemistry in 2023 is presented to Dr. Arup Kundu. For the mechanistic understanding of singlet fission dynamics in complex molecular systems. An honorable mention, chemistry in 2023 is presented to Dr. Mohammed Tahir for the design and development of artificial metalloenzymes. An honorable mention is also presented to Dr. Sabyasachi Chakraborty for quantum chemical explorations across diverse chemical spaces. The Harish Chandra Memorial Best Thesis Commendation in Mathematics in 2023 is presented to Dr. Prahlad Kumar Sharma for his original contributions to the convexity problem for automorphic L functions, applying newly developed tools in difficult cases of this problem. An honorable mention in Mathematics 2023 is presented to Dr. Animesh Jana for his uniqueness results for Euler equations, for Euler equations and for catastrophic examples in the theory of hyperbolic conservation laws. Thank you. It's been a privilege to recognize these wonderful students. I will now hand over to Sana.
Apart from the best thesis, the Endowment Fund has instituted commendations for excellence in teaching at TIFR. I again request Professor Pole to announce these honors.
The Excellence in Teaching Awards come not only from nominations from the student community, but also from the deliberations of the committees. The subjects that these awards are awarded in are scaled approximately to the numbers of courses offered in these subjects each year. So physics is offered every year and the other subjects come every other year or so. So don't be surprised if some years have some subjects and not others. And again, we will be awarding for last year as well as this year. The B.M. Udgaonkar Excellence in Teaching Commendation for Physics in 2022 is presented to Professor Abhishek Dhar. For his significant contribution to designing the graduate coursework at ICTS TIFR and his excellent approach to teaching complex concepts with rigor and clarity. The B.M. Udgaonkar Excellence in Teaching Commendation in Biology 2022 is presented to Professor Apratik Mazumdar. For his strong commitment to research-oriented teaching and for imparting training in essential science communication skills. Apratik is currently teaching a class which he didn't want to cancel to come here for the event. The B.M. Udgaonkar Excellence in Teaching Commendation in Mathematics 2022 is presented to Professor Venkateshwaran Krishnan. For sustained excellence in teaching and mentoring of students. And now the commendations for 2023. The B.M. Udgaonkar Excellence in Teaching Commendation in Physics in 2023 is presented to Professor Rajdeep Sen Sharma. For significant and sustained contribution to graduate school through teaching well-structured and engaging courses. The B.M. Udgaonkar Excellence in Teaching Commendation in Computer and Systems Sciences in 2023 is presented to Professor Piyush Srivastava. For his ability to convey the central idea beautifully to students. the B.M. Adgankar Excellence in Teaching Commendation in Science Education 2023 is presented to Professor K. Subramanian. For significant contributions to the graduate program at HBCSE and sustained excellence in teaching and mentoring students. Thank you. I'll hand over to Sana.
Thank you, ma'am. Thank you, sir. Next, we have staff commendation ceremony, where we acknowledge and appreciate the dedicated efforts of our staff members. Their efforts are the backbone of our institute, and we are deeply appreciative of their contributions. We first honor those who have completed 25 years of continued service in TIFR. The recipients are requested to walk up on stage in the order shown on screen when the names are announced. I request the registrar, Colonel Anand, to announce the recipients of these medals and the director to hand over the medals. Thank you.
The recipients of the 25 years service medal are Mr. Yogesh Arora, Mr. Ansar Aziz, Sri Shailendra Bagde, Shailendra Bagde, Mr. Rajendra Chogle, Mr. Vikas Durgavali, Mr. Gangadhar Bhutraj, Mr. Subhash Gaikwad, I think he is not present here today, Professor M. Krishnamurthy, Mr. Vijay Kurkure, Professor Sudipta Methi, Mr. Umesh Morje,
Rabindra Munshi. Dr. Vandana Nanar. Mr. Radharam Nikumbe. Professor Sri Ganesh Prabhu. Ms. Pramila Kumari. Shri Prashant CM. Mr. Muhammad Rahman. Mr. Ramdas Shilavle. I think he's not there with us in this meeting right now. Mr. Anand Shinde. Professor R. Saudamani. And lastly, Mr. Harish Chandra Tambe.
Thank you, sir. I request the director to stay on stage, please. We now come to the spot achievement certificates. These are to honor the staff members who have served the institute beyond the call of their duty. I request Professor Sri Rai Chaudhary, Dean Administration, to announce these recipients.
So the spot achievements are given for those who have performed something which is outside the regular call of duty, who have done something extraordinary, something which they are not trained for, something which they have stepped out and done something new, something out of the box. And we recognize such achievements by the Spot Achievement Award. So I will start with Mr. Raju Kumar. Mr. Kumar's outstanding achievement during the year 2021-22 for his positive attitude and initiative in repairing the 4 defective Bosch CCTV cameras in-house with great effort and innovation, where no repair agency in Mumbai was willing to undertake the same repairs. This was during the pandemic, thereby saving valuable time and 10 lakh rupees to the institute. Next, we have Mr. V.R. Olvin. Mr. Olvin's outstanding achievement during the year 21-22 was in designing and building a hypoxia chamber, Bluetooth data transmission system, temperature control stage 4 dissection microscope, LNW low-level temperature monitoring system, and power supply control system and microscope using P-card.
Mr. Sachin R. Kohli. Mr. Sachin Kohli's outstanding achievement during the year 2021-22 was for his initiative shown in assigning unique identification number to 900 plus electrical items within the electrical stores, which helped to readily identify the status of the electrical items inventory. Mr. Kohli. We now come to the Spot Achievement Awards for 2023. Mr. G.N. Deshmukh. The Institute places on record its appreciation of Mr. Deshmukh's outstanding achievement during the year 22-23, namely for the initiative and positive attitude shown in voluntarily learning the physiotherapy modalities and imparting these to patients as advised by the physiotherapist, which was of an immense help to the HPC during a period of difficulty. Mr. A. Sampath. The Institute places on record its appreciation of Mr. A. Sampath's outstanding achievement during the year 22-23, namely in designing, fabricating, and deploying the new boom structure for the balloon payload launch vehicle for balloon flight, resulting in saving of time and improving the effectiveness in the method of launch. The next award goes to a team. May I request all the members, MD Pawar, PM Khilare, VD Shinde, J Patharwala. Can you please all come on stage? Can we have the lights for a photograph with the director? The Institute places on record its appreciation of Mr. M.D. Pawale, Mr. P.M. Khilare, Mr. V.D. Shinde, and Mr. J. Patharwala for their outstanding achievement during the year 22-23, for being part of the team which helped in fault tracing in the operation of the 625 kVA DG set AMF panel, rectifying and modifying the motor, and fixing the motor in the breaker. One more teamwork. May I request all the members to come on the stage? P.S. Bagal, D.D. Kadam, V.S. Paushe, D.R. Matre, D. Ahmad, P.S. Margaje, L.T. Talpade, S.V. Pandav. The Institute places on record its appreciation of these gentlemen for their outstanding achievement during the year 22-23 for being part of the team which fabricated a unique stand without ceiling support, fabricated new chilled water lines, and laid them with modern insulation and identified leakage of fresh water in the vast network of chilled water system and fixed it. Please stand by for a group photo with the director. I briefly hand you back to Sana.
I request Professor Rai Chaudhary to also announce the Lifetime Distinguished Service Medals. Through these medals, we honor those staff members who have served the Institute over their career with a great sense of dedication and diligence.
So the first of these goes to Mr. B.L. Gamre, just to record. Mr. B.L. Gamre, now work assistant F, joined the Institute in 1981 as cleaner. He has worked tirelessly for more than 41 years in the Institute. He has been sincere, hardworking, and enterprising throughout his career. Please give him a big hand. Mr. M.A. Gurav. Mr. M.A. Gurav, now work assistant F, joined the Institute in 1985 as courier peon. He has worked tirelessly for more than 36 years in the Institute. He has been sincere, hardworking, and enterprising throughout his career. Please put your hands together for Mr. Gurav. So now this brings us to the awards for the current year. So the first one goes to Mr. A. Jaitapkar. Mr. Jaitapkar, now a technical officer D, joined the Institute in 1986 as tradesman B. He has worked tirelessly for more than 37 years in the Institute. He has been sincere, hardworking, and enterprising throughout his career. Last but not least is Mr. L.V. Kamre. Mr. L.V. Kamre, laboratory assistant H now, joined the Institute in 1988 as temporary helper B. He has worked tirelessly for more than 35 years in the Institute. He has been sincere, hardworking, and enterprising throughout his career. Big hand for Mr. Kamre. That brings us to the end of this set of awards. I now hand you back to Sana for the remaining program.
Thank you, sirs. As we near the end of this memorable day, I would like to invite Professor Basudev Dasgupta, convener of this year's Founders Day celebrations, to deliver the vote of thanks. It is an opportunity for us to appreciate the collective efforts that have gone into our.
Thank you, Sana. It's a pleasure to thank a large number of people who made the organization of this year's Founder Day events possible. So I begin by thanking the director for his support and guidance and personally attending and initiating the program, giving away the prizes. So please put your hands together for our director, Professor Jairam Chengalur. We were also very lucky to have as our chief guest, Professor Kasturirangan. He had to leave after the interval, but we were very lucky to have him. And we thank him for accepting our invitation and presiding over the Founders Day function. We thank the Dean of Administration for his support and guidance throughout and doing the honors on stage. So please put your hands together for Professor Rai Chaudhary. We thank the Registrar, Colonel Anand, and the Deputy Registrar, Sanjay Gokhleji, for his support and guidance. We thank today's public speaker, Professor Mahan Maharaj. He's also the Dean of the Mathematics Faculty, for delivering today's Founders Day public lecture, Dimensions 1, 2, 3, and beyond. So please put your hands together for him. We thank Professor Shubha Tole, Dean of Graduate Studies, for her support and for announcing the academic degrees and commendations. It's also a pleasure to thank previous conveners of Founders Day events, Professor Rajdeep Singh Sharma, Orkodev Chatterjee, and Professor Amol Dikhe. I also thank Dr. Satyanarayan Pisetti for taking complete care of the YouTube and the Zoom arrangements. Please put your hands together for him as well. I also thank Professor R. Vijay Raghavan and Vaibhav Desai for arranging the cultural program that you will hopefully attend on the 5th of November. It's my pleasure to thank Mr. R.D. Chogle for inspecting and smooth delivery of the 25 years service medals and the lifetime distinguished service medals. It's a pleasure also to thank the catering committee, Mr. A.V. Tambe and his team, as well as the chair of the canteen committee, Professor Singh Sharma, for arranging for tea, which we happen to have a little earlier than planned today, but we have to thank them that it was ready on time. Thanks. I also thank Mr. Gumaste and his team for organizing the plantation drive. Many of us planted trees in the morning today, and also for organizing all the floral bouquets and gardens. It's my pleasure also to thank Ms. Oindrila Rai Chaudhary and her team at Archives at TIFR for arranging a beautiful exhibition on the connection between TIFR and the space research in this country, in ISRO. And we were lucky also to hear beautiful remarks by Dr. Kasturirangan, which more or less covered the same ground. So let's put our hands together for Oindrila. It's my pleasure also to thank the arrangements committee headed by Mr. Kishore Kajrolkar and his team for taking care of all the requirements that have been put to them from various subcommittees of the Founders Day Apex Committee. I thank Mr. Bharat Joshi and his entire security team for organizing several events, including the cyclothon yesterday, and for providing overall security and transport arrangements, including the issue of visitors' passes to various members who had to attend. I thank Dr. Sandhya Raghavan for organizing a blood donation camp on the 6th of November, and also for providing medical help wherever required. It's my pleasure also to thank Professor Arnab Bhattacharya and his team from HBCSE for organizing a science mela on the 5th of November, and also for providing various other help during this enterprise. Thanks very much. I also thank Mr. Surya Balan. He's the secretary of the Students' Cultural Committee and also the TIFR Student Society for organizing a beautiful art and photography exhibition outside. Please do take a look. It'll be here until the 5th of November. I thank the TIFR Sports Club and especially Mr. Danishwar Avhad and Mr. Shashikant Kadam for their team. They have organized a variety of sports activities over the last week or so, and it's a very large effort and they've been very enthusiastic. So let's give them a big applause. We also thank the photography section, Mr. Jatin Acharya and Mr. Vijay Shinde for covering all the events. Hopefully we'll get to see some of these photographs later on. So please put your hands together for them. Mr. H. Raghavan and his team for making the required arrangements in the auditorium and the foyer area throughout the period of rehearsal and this program in the auditorium. Let's thank them. I also thank the electrical staff of the technical services section of TIFR, again, throughout the period of rehearsal and the program in this auditorium. We thank the cosmetic maintenance department and Mr. M.V. Raje and his team for all the arrangements that they have made. Let's thank them as well. I assure you, just 3 or 4 more names. It's very important that we thank everybody who contributed to this event. We thank the in charge of the guest house, TIFR and HBCSE for providing accommodation to some of our out-of-station participants. I thank Ms. Sana Naim Sheikh. A big round of applause for her, please, for comparing today's event. I'd like to thank every member of the APEX committee for their valuable guidance and support in organizing this program. And lastly, but certainly not least, perhaps most importantly, I'd like to thank all the staff, but in particular, the team at General Administration, especially Mr. Shirke, Mr. Felix, for all the help that they have provided in organizing this year's Founders Day event. The events will continue over the next week, in particular the photography exhibition and the cultural and sports events on November. So please put your hands together one last time and thank everybody who made this event possible. I thank you all for coming and hope to see you all again on 5th of November. Thank you all.
For the convenience of our attendees, we have made arrangements for buses to drop off those who are heading towards CST and Churchgate stations. Thank you.